continue chapter 8. So today we're going to mainly focus on integrals, including sine and cosine. 8.3. Integrals with sine and cosine. So let's go over one example to see what's going on. Suppose you have the integral of cosine to the fifth of x dx. Here you have cosine to the fifth power. 5 is an odd number. 5 is odd. So very well. Let me rewrite cosine to the fifth as cosine to the fourth times cosine x dx. Also, cosine to the fourth can be written as cosine squared raised to the second power. So this integral is equal to cosine to the second raised to the second. So let's copy down the rest of it, cosine x dx. At the same time, I know that cosine squared is equal to 1 minus sine squared. Very well. So if I write 1 minus sine squared or cosine squared, I can use substitution. Take a look at this. This guy is equal to the integral 1 minus sine squared x raised to the second power, and I have cosine x dx. Well, so let u be sine of x, du is going to be cosine x dx. I'm going to use substitution. So this is equal to the integral 1 minus u squared raised to the second power, and this by cosine x dx is nothing but d. There you go. To take this integral, let us write it in expanded form. This is equal to integral 1 minus 2u squared plus u to the fourth and du. Now I know how to find this integral. By using the power rule, you get the integral of 1 is u, the integral of 2u raised to the second power is minus 2/3 u to the third, and the integral of u to the fourth is u to the fifth divided by 5. Very good. And original integral is in variable x, so we have to rewrite this expression having x in it. So what is u? U is nothing but sine of x. So wherever you see u, you just quickly write sine of x. You get sine of x minus 2/3 sine to the third of x plus sine to the fifth of x divided by 5 plus constant of integration. So note that when the exponent is 5, we can separate these into the product of cosine and cosine, then we can convert cosine into sine and take the integral. Now, what if we have just even exponent. Take a look at this. Suppose you have sine to the fourth of x. And the exponent 4 is an even exponent. Very good. In this case, we are getting back to pre-calculus through functions. This guy is sine squared of x raised to the second power dx. Remember that. Sine squared of x is 1 minus cosine 2x divided by 2. So our goal is to reduce the power to exponent and write it in the format that we can actually take the integral. So this integral can be written as the integral of 1 minus cosine 2x divided by 2 raised to 2 dx. Sine squared can be written as 1 minus cosine 2x divided by 2. Okay, let us raise it to 2, see how we can simplify this more. This is the integral 1 minus cosine 2x raised to the second power divided by 4 times dx. So we can write a 4 in front of the integral. We get 1 minus cosine 2x raised to 2 dx. This is equal to the integral. So we wrote 4 in front of the integral. 1 minus 2 cosine 2x plus cosine squared of 2x dx. I'm good with 1. I'm good with 2 cosine 2x, but my cosine here has exponent 2. Somehow I have to reduce this cosine squared. Again, if we get back to pre-calc, cosine squared of x is equal to 1 plus cosine 2x divided by 2. Now here we have cosine squared of 2x. So cosine squared of 2x is 1 plus cosine 4x divided by 2. So this integral is equal to 4 integral of 1 minus 2 cosine 2x plus cosine squared, which is 1 plus cosine 4x divided by 2 dx. Very well. So you have a 4. The integral of 1 is just x. The integral of cosine 2x, it has 2 next to it, so you get minus sine 2x plus a half x plus a half. This guy, if you apply substitution, it must have coefficient 4. It doesn't have coefficient 4, so if you multiply and divide by a 4, this is the integral of sine 4x. Finally, we can simplify this into a 4, x divided by 4, minus sine 2x divided by 4, plus x over 8 plus 1 over 8 sine 4x plus c. So here you have 2x divided by 8 plus x over 8. You get 3x divided by 8 minus sine 2x divided by 4 plus sine 4x divided by 8 plus constant of integration. So a 4 here, a 4 here, and here 1 over 8, and here I have 2 times 8, 8 times 4, 32. So this is 32. And the denominator is 32. Thank you. So far we saw that if we have odd exponents, if we have even exponents, now we're going to see what's the combination of odd, even exponents, and so on. So take a look at this. So we moved on to the next page, page 2. What if you have the integral of sine to the 4th of x, for example, times cosine squared of x dx. So what do we have here? We have sine raised to an even exponent, cosine raised to an even exponent. So both exponents are even. There you go. We know that this one is not that hard. We know that cosine squared of x is 1 plus cosine 2x divided by 2. And we also know that sine squared of x is 1 minus cosine 2x divided by 2. So let us go. Here we have the integral. Sine to the 4th can be written as sine squared raised to the 2nd power times cosine squared of x. This integral is written as sine squared is 1 minus cosine 2x divided by 2 raised to the 2nd power. The second integral, the second function is cosine squared is 1 plus cosine 2x divided by 2 dx. Very good. Now we raise this expression to the 2nd power and try to see what do we have. This part is equal to the integral of 1 minus 2 cosine 2x plus cosine squared of 2x divided by 4 times 1 plus cosine 2x divided by 2 dx. Very well. I can multiply 2 and 4, and I can write it outside the radical. Dx. So this is the integral 1 over 8. Now I'm going to multiply this trinomial and this binomial and try to simplify this as much as I can. So more space. Let me write it down here for you. 1 over 8, the integral, 1 times 1 times cosine 2x, negative 2 cosine 2x, negative 2, cosine squared 2x, and finally, let's distribute cosine squared of 2x here. We get plus cosine squared 2x plus cosine to the third 2x, and finally I have dx here. You're looking for like terms? Like terms. So here you have negative 2 and you have 1, so this is equal to 1 over 8. The integral, so only have one constant, so let's copy out the constant. Here, if you combine these two, you get minus cosine 2x. I'm combining these two. Then we can combine these two as well. Minus cosine squared 2x plus cosine cubed 2x dx. Very well. I'm good with 1 because 1 is just a constant. I'm good with cosine, this is good. But for cosine squared, I have to write this in the format that I get rid of exponent 2 and write it in simpler form. The same for cosine to the third. I have to rewrite this integral. Very well. Dx here. So I get 1 over 8. The integral 1 minus cosine 2x minus 1 plus cosine 4x divided by 2. And for this one, I have plus cosine 2x times cosine squared 2x dx. At the same time, cosine squared can be written as 1 minus sine squared 2x. So this is equal to 1 over 8, the integral 1 minus cosine 2x minus a half minus cosine 4x divided by 2. Here I have plus cosine 2x times 1 minus sine squared 2x dx. So let me erase these formulas for you. So I continue writing the rest of it here. Okay, that's fine. So here you have 1 over 8. 1 over 8. The integral of 1 is equal to x minus the integral of cosine 2x is a half sine 2x. Negative a half, so let me combine these two here. This is positive a half, so I don't have to deal with this 1 over 16 x. And here, so let me write 1 over 8 outside, then distribute. It's easier that way. So the integral of cosine 2x is a half sine 2x. Then here you have cosine 4x divided by 2. So when using u solve, we need to see 4 here. We don't have 4, so we divide by 4 as well. We get minus sine 4x divided by 8 Then for this one, you distribute cosine 2x. When you distribute cosine 2x, you get plus a half sine 2x, and eventually you're left with the integral of sine squared 2x times cosine 2x dx. Sine 2x divided by 2 minus the integral cosine 2x sine squared 2x dx. And this one is inside parentheses. So finally, what do we have? By using u sub here, you get u to be sine 2x. U is sine 2x, and du is 2 cosine 2x dx. So since we don't have 2, we multiply and divide by 2. And eventually what do we have? Is going to be 1 over 8 x over 2 minus sine 2x divided by 2 minus sine 4x divided by 8 plus sine 2x divided by 2. Okay, very well. Here, these two are opposite of each other, so you can actually cancel out these two. Makes it easier for us. Minus sine 4x divided by 8 minus. So if sine 2x is your u, you get a third times a half u to the third. Sine cube 2x divided by 6 plus constant of integration. Then we can distribute 1 over 8 here and simplify this more. Next example. Now suppose you have this integral. You have integral sine to the third of x cosine minus 2x dx. Very well. Let's see. So here you have a negative exponent, and here you have sine to the third. How can I get rid of this negative exponent? Sine to the third is actually sine squared times sine. So you can write this as sine x times sine squared of x, and copy down your cosine to negative exponent here. Sine squared is 1 minus cosine squared. So this is the integral of sine x, 1 minus cosine squared of x, and here you have cosine to negative 2 dx. Now distribute this guy into parentheses. You get the integral of sine x cosine to minus 2 minus cosine squared times cosine to negative 2. You add the exponents, it's going to be 0. Cosine to 0 is just 1 dx. There you go. Okay. Now it makes sense to use u substitution. If you rewrite this as the integral of sine x times 1 over cosine squared of x minus 1 dx. This is actually the integral of sine x over cosine squared of x minus sine x dx, which is easy to work with. Here you can take u to be cosine x, du is minus sine x dx. So the first integral is now converted into the integral of minus sine x dx divided by cosine squared of x with a negative sign in front of it. And the second integral is minus sine x dx. So here you have minus integral du divided by u, and you already know that the integral of sine is negative cosine. So here we go. And this guy has exponent 2. The integral of u to negative 2 is minus u to negative 1 over negative 1 plus cosine x plus c. So what is u? U is cosine x. So this guy is equal to minus minus plus 1 over cosine x plus cosine x plus constant of integration. In this step, you could say that I have sine over cosine, which is tangent, 1 over cosine, which is secant. The outcome is equal to secant. So as you can see, 1 over cosine x is secant. If you remember the formula, use the formula. If you don't remember the formula, you can use u sum. Okay, guys, let us start 8.4. Trig substitution. So let's see. 8.4. Trig substitution. So sometimes you have integrals like this format. The integral of square root of a squared minus x squared dx. Very well. How do you take this integral? When it comes to cases like this, we use trig substitution. So how it works? Consider a unit circle or just a circle in general. So suppose your radius is equal to a, and the angle here is theta. Very well. We can form a right triangle with theta here, a as the hypotenuse or the radius. And on x-axis, this portion is just, let's say, let me call it a note. So this is one side. One side of your right triangle, and this is the other side. Okay, perfect. So suppose we form this right triangle, and we are using the sides to be a as x, a the hypotenuse, x, and our goal is to find, this is just an angle like theta, our goal is to find this side. Or suppose this is x and you want to find this sum. So for different triangles, if you have the hypotenuse, you can use the definition of sine, cosine, and actually find the rest of the sides or legs of this right triangle. Okay, perfect. So how did we define sine? If you remember the definition of sine function is coming from a right triangle. Sine of theta is defined as x divided by a. And at the same time, Pythagorean theorem says a squared is equal to x squared plus this length raised to the second power. So this length here, question mark, raised to the second power is equal to a squared minus x squared. So this length here is nothing but square root of a squared minus x squared. So cosine theta is equal to adjacent a squared minus x squared divided by. You can do the division between these two and find tangent or flip them to find cotangents. So as you can see, we can connect any integral having square root of a squared minus x squared to a right triangle. Example. Let me give you an example and show that how we can use these formulas. So in this example, the question says, verify that the area of a circle, of radius A is 4 pi. This pi is okay. So how do we do that? Remember a circle. How do we find the area of this circle? So the area is equal to the integral, since it has 4 equal sub-circles. So you have 1, 2, 3, 4 equal portion. You find just one little area here and multiply it by 4 to get the area. So it is equal to 4 times, suppose this is R, 4 times R, and you get your area. Okay, but what is this R? What is this area? R is equal to the integral 0 to whatever it is, 0. What is the radius? The radius is equal to A, 0 to A, of the function. What is this function? F of x dx. What is this function? How do you find this function? So, equation of a circle centered at the origin with radius a is x squared plus y squared equals to a squared. So y squared is equal to plus minus square root of a squared minus x squared. So your f of x is positive square root of a squared minus x squared. This function here is y equals to square root of a squared minus x. So we found the function f of x or y is equal to square root of a squared minus x squared. Very well. Now for the integral. Area is equal to the integral 4 times integral of f of x, which is your y, square root of a squared minus x squared dx. As I mentioned, here you can use the substitution using Greek functions. So a times sine theta is equal to your x. Take a look at this. From this equation, you get x equals to a sine theta. So wherever you see x, you write a sine theta, and dx is equal to a cosine theta. And since we are taking just this portion of the circle, theta ranges between 0 to pi over 2. So this integral is now 4 times 0 to pi over 2 square root of a squared minus a squared sine squared dx, which is a cosine theta d. The rest is not that hard. Here you can factor out a, you get 4 times a, the integral 0 to pi over 2 square root of 1 minus sine squared theta, which is cosine squared, times cosine theta d theta. This is equal to 4a squared integral 0 to pi over 2. The integral, the square root of 1 minus sine squared is cosine squared. So this guy is nothing but cosine theta times cosine theta d theta. You get cosine squared of theta. So this integral is 4a squared integral 0 to pi over 2 cosine squared of theta d theta. Cosine squared is 1 plus cosine 2 theta divided by 2. So this is equal to 4a squared integral 0 to pi over 2 4 pi 4a squared, the integral of cosine squared of theta 0 to pi over 2 d theta, which is equal to 4a squared 0 to pi over 2 1 plus cosine 2 theta divided by 2 d theta. This guy is equal to 4a squared. So 1 over 2, theta over 2. And here you have cosine 2 theta. You get a 4 sine 2 theta. And theta ranges between 0 to pi over 2. So let us plug in pi over 2. Then we plug in 0. We're not worried about 0 because this guy has theta and sine of 0 is also 0. So forget about your 0. Just focus on pi over 2. You get 4 a squared theta is equal to pi over 2. So you get pi over 2 times 2, pi over 4. And 1/4 sine of pi is equal to 0. So the outcome is equal to pi. Next example. Let's keep this here. We move down to page 2. So now here we have the integral example. Here we have this integral, which says we have dx divided by 16 minus x squared raised to 3 halves. Okay. So you have 16 minus x squared. Remember that your x can be written as a sine theta, and a as a hypotenuse is just as radius is just a number. Okay, let's see. So I have 16 minus x squared. 16 minus x squared. I have the general format of a squared minus x squared inside the radical. So compare these two. A squared minus x squared. What is a? A is equal to 4. So we can say that, hey, I'm going to use trig substitution by taking x to the 4 sine theta. Now dx is equal to 4 cosine theta d theta. Very well. So we can rewrite this integral as the integral of 4 cosine theta d theta divided by 16 minus 16 sine squared theta raised to 3 halves. Very good. So let us simplify this guy and then try to take the integral. On the denominator, here you have, so let me rewrite the numerator for you. On the denominator, here we have, if you factor out 16, we get 1 minus sine squared theta, everything raised to 3 halves. This integral is equal to the integral 4 cosine theta d theta divided by. Okay, 16 is nothing but 4 squared. So you get 4 squared raised to 3 halves. 1 minus sine squared is cosine squared of theta raised to 3 halves. Very well. I can cancel out 2 and 2. I can cancel out 2 and 2. What do I get? I get the integral 4 cosine theta d theta divided by 4 times 16 cosine to the third of theta. Very well. So simplifying the whole thing, you can cancel out 4 and 4. You can cancel out 1 cosine and 1 cosine. You get the integral of d theta divided by 16 cosine squared of theta. So this is 1 over 16 integral of secant squared of theta, d theta, which we all know it is tangent. So the outcome is 1 over 16 tangent of theta plus constant of integration. So in general, if you have integrals of these forms, you can use trig substitution. When you have a squared minus x squared inside your integral, you can take x to be a sine theta. When you have a squared plus x squared, the substitution is x equals to a tangent theta. And if you have x squared minus a squared, the substitution that you can use can be a secant theta. Secant theta. Then, as I've shown you in previous examples, you can just simplify your integral, and by converting them into sine, secant, which is 1 over cosine, and tangent, you can take those integrals.